Hello and welcome to Algebra 1, Chapter 3.5, and today we're going to discuss proportional and non-proportional relationships. So first of all, we'll talk about proportional relationships, and it's a relationship that has to fit the following three criteria. So first of all, it has to be linear. Okay, so if we look at our data over here that's plotted, notice that they do make a line, so this is linear, all right? It has to be something that can be written in the form y equals kx, where k is some constant, okay, and it has to pass through 0, 0. And so that's the big one that makes lines be proportional. And if we look here, so we have volume of water and volume of ice. So if I just extend this table here, if I had 0 water, how much ice would I get? I would have 0 ice, right? So this is going to pass through 0, 0, and if we worked our way back on these points here, it would pass through 0, 0. And so let's look real quick. Could we write an equation that was y equals something x, okay, and it says where k is the constant. So if we look, let's see, 11 is 12, 22 is 24. Let's try, and I'll explain more later how I got this. Let's try 12 over 11. So if that's my equation, then when I go and I put in a number, so let's say we put in 33. So if I put in 33, the question is, does this give me 36? Well, and that would reduce to 3, and 12 times 3 is 36. So yes, that gave me 36. And so you could continue if you wanted to try it out. So if I put in 55, well then that's going to reduce to be 5, and that would be 60. Okay, so it would be my k value, 12 over 11. What I did is that is my my change in y over my change in x. That's how I got that. Alright, so this is a proportional relationship, and just to mention deductive reasoning is using a pattern to find a relationship. So this pattern here, this table, this graph, using the pattern to find the relationship. So that's what I just did to find this k value, is I used this pattern. And that's called deductive reasoning, to use some pattern, something that's been happening, to figure out some information from. Okay, so here we have hours driven and miles that we have traveled. And first of all, it says to graph the data. Okay, well, remember that we always put labels on our axes. So we're going to start down here with hours, and miles will be over here. And for hours, I think we could just count 1, 2, 3, 4, right? And notice we started at 0, right? The y-axis, if this was the first quadrant here, y-axis would be 0. Okay, miles though, we gotta go to 250. We could spread it out, and we can make that one be 50, so we're counting by 25s. 100, 150, 200, 250. And we're just going to plot these points. So we're at 150, 2 100, 3 150, 4 250. Okay? So what conclusion can you make about the relationship between the number of hours of driving and the number of miles that you've driven? Well, first of all, if we look here, this is not going to be linear. And why isn't it going to be linear? What messed us up? It was this last one messed us up, right? So tell you what we're going to do, let's change that to be 200. And then, are we linear? Okay, now not that you can just change the data, but let's change that. Because I don't think in an hour that you're going to drive 100 miles. That would be you have to drive 100 miles an hour. So our table here is wrong. Okay, so what conclusion can you make about the number of hours of driving and the number of miles driven? Well, how many miles are you driving per hour? You're driving how many miles every hour? You're driving 50 miles every hour. Notice that this is going to be proportional because this line would go through 0, 0, right? If you have driven 0 hours, you've driven 0 miles. Okay, it's linear. And what we're going to do next is we're going to write an equation for this. Now instead of writing y equals kx, we're going to do this in function notation. So we're going to do f of x equals, okay, y is the same thing as f of x. I'm just replacing y with f of x. And so k is this number right here. What is happening? We're going to go 50 miles per hour times x hours. So there's my equation. So if I put in 3 for x, right, if I want to evaluate f of 3 just to make sure this works, 50 times 3 is 150. It's right there. There we go. Okay, so that was proportional. Let's look at non-proportional. So a non-proportional relationship is still linear. This time, though, it just doesn't pass through 0, 0. And so what you have to do at the end, if this is my equation for proportional relationship, you have to do plus or minus some number at the end to move the equation up or down. So in this case, because the equation is moved up 3, 1, 2, 3, we would put a plus 3 at the end. Okay, so let's look at one of these. So we want to write the equation in function notation for the relationship graph. And it says we're first going to make a table of ordered pairs. So let's make a table. So here's my table. So it looks like 1, 1 is in my table, 2, 4, 3, 7, 4, 10, and 5, 13. Okay, there's my table. Find the domain and range differences. Okay, so what's happening here? We're going up by how many every time? Plus 1. What's happening over here? Every time plus 3. Okay, and so when we write our equation, f of x equals, we're going to take, remember I wrote earlier, the change in y over the change in x. So that is going to be 3 over 1x. And then is this going to go through 0, 0? It's not. If I draw on this line is going someplace below 0. So let's just go backwards. If I go backwards 1, that would be 0. And if I go backwards 1 over here, what would that be? Be negative 2. So I have to cross at negative 2. So we're going to do minus 2 because that graph crosses. Its y-intercept is at negative 2. All right, there you go. We will discuss questions in class, but let me know if you have any. If not, have a great day.